Hi. Bless off. Welcome back. Good morning. Good morning. I do see a few electronics out. Do me a favor, just slide those off to the side for now. You can play with them again later. Because we're working on this thing. What is this thing?
It's a parabola.
Yeah, it's a parabola.
Parabola.
Parabola. That, you know what? That's exactly how I have to say it in my head to spell it properly. Because otherwise, I misspell it every single time. It's a parabola. Parabola. It's a parabola. It looks like this. This is what the parent function of that thing looks like. It's just x squared. Which means that we can apply all of our transformations that we've already looked at with lines and with absolute value to this thing, and we can stretch it, and we can squish it, and we can flip it, and we can slide it, and we can do all those things. We're not going to do those today. Relax, calm down. I know you were excited about it. We'll do those later. For now, let's just graph some points and practice drawing the curvy thing that is the parabola. Please make sure I come back to these 3 plus signs at the very end. So when we're done, yeah, so miss, don't forget the plus signs so that I remember I have to come back to these, okay? Okay. So here's our table of values and some graph paper. We have our x values, our y values, we're going to graph them. While you guys are starting to graph these, and I know a lot of you are already doing that because you're super excited to draw the graph of the thing and the stuff, I want to talk really quick about what's happening right in here, okay? So while you guys are graphing, I want to chat about what's happening in here. So this says -2 squared, which means take -2 and multiply it to itself 2 times. +4. This does not say, if you're going to use the TI Inspire calculators to figure this out, you should not write it this way. The parentheses become important because I'm going to point at it and I'm going to say each one. I want you to listen very closely to the difference. This is our math language happening. Ready? This one says -2 squared. This one says -2 squared. You hear the difference? I emphasize, and that tells you what you need to do first. Because this says -2 squared, you're going to square -2, and you're going to multiply -2 to itself 2 times. Whereas this one says -2 squared, I'm going to square the 2 first, 2 times 2, and then with the results of that, I'm going to stick a negative on it. This is why if you've ever seen this one and typed it into the calculator this way and you've said -4, your teacher goes and puts a big red X on it. Because the calculator doesn't understand the difference on these unless you tell it. And the parentheses is you telling the calculator, and everyone really, which thing you want to happen first. The top one says square -2. The bottom one says square 2 and then make it negative. If that was an aha moment for you, jot this thing down somewhere in your notes so you have it. I'll leave this up there for about 30 seconds, and then I'm going to get to graphing this thing. So whatever you need to know to remember, remind yourself, find some space. The top one again says -2 squared. The bottom one says -2 squared. All right, I'm going to start graphing some values then. Just going to zoom it out here a little bit so you can see what I'm doing. And I'm making my points really big and obnoxious so that you can see it a little more easily. Okay, 3 ends up over here somewhere. I didn't need to graph this one out here, but I did. All right, so here's the points. When we were doing absolute value, like last week, we were using our straight edges, and we were using straight lines to connect the points. And so if I tried to do that exact same thing here, yeah, I gotta curve it. So I gotta put some sort of bend. I guess if you want to really like get fancy with it, you could use, I don't think that's the right curve. That could work maybe. I kind of missed it a little bit, so that isn't the right curve to use. Yeah, so you know what? I'm gonna do it by hand here and, oh God. So I'm not gonna be like super strict on, oh my God, it's not the right perfect curve. As long as it looks curved as opposed to you took a straight edge and connected everything with straight lines, I'm gonna be happy, okay? So just use your imagination to make those curves the best that you can. Let's talk about some characteristics of this thing, because we can talk about those now. X-Intercepts.
None.
Good. This homework assignment doesn't ask you to list these out, but it will soon. And if you do, please make sure you write none, or doesn't exist, or there aren't any, or empty set, or something that tells me that you recognize that these don't have any. Because if you just leave it blank, I don't know if you're telling me there aren't any, or I don't know what I'm doing. And I'm going to have to lean toward the I don't know what I'm doing. Okay? Y-intercept.
0, 3.
You guys are really good at this. All right, what are the kind of characteristics?
It's a parabola.
It's a parabola. What
It's
kind?
minimum.
There's a minimum happening here.
Because I'm never sure if it's a minimum or a maximum.
Okay, great. So if I imagine this is like a cup, can I hold something in it?
Yes.
Then the minimum. Otherwise, it's a roller coaster and stuff rolls off.
Okay.
Maximum.
And it's the same with that sort of value?
Exactly the same, except it's more sharp.
Oh, okay.
So we can talk about a minimum. What else can we talk about on this thing?
The little,
It's a positive parabola, so it's increasing. Okay, we could talk about that. What did you say?
the solutions or something?
The solutions. Okay, I heard you. Solutions. Can I hold that in my back pocket for like about a week or so, and then we'll come back to it? Okay. You had said axis of symmetry. I like this. You remember that. Can you give us a guess on where you think axis of symmetry would be?
Isn't it where it cuts in half?
Yes, it does. Can you tell me what kind of line I should draw? She did it with her finger like this. What's the word for this one?
A straight
It's a
Vertical line, yes.
vertical.
So I'm gonna put the vertical line right here in the middle, right through the vertex. What's the equation type of these vertical lines? Is it an x equals something or a y equals
Y
something?
equals.
It's a y equals.
X equals, it's an x equals. If it's vertical, okay, I know, but the x is a horizontal line. It's because this is how it gets drawn, and so we're looking at all the possible x values, and there's only one.
Oh.
So this is an x equals kind of line. And you said it was at 0? Now, I had said something about where the axis of symmetry went through. Do you remember where I said it went through? The vertex. So, does this thing appear to have a vertex?
Yes.
Ooh, nice. Where?
3.
0, 3. Beautiful. We could talk about domain and range. Okay, let's do it. Domain. Yeah, all real numbers. Because we have those arrows on either side, and we can imagine this cup getting wider and wider and wider the taller that it gets. And sure, it's going to take a long time before it gets like super wide to infinity, but it'll get there. So we can write all real numbers, or we can write our infinities, whatever you like the best.
Miss, I might get picked up random.
Okay. Totally random.
No, it's because I forgot.
It's okay. It's all right. It's all right. It's okay. What about range? Greater than or equal to 3. Y is going to be greater than or equal to 3 always, because 3 is our minimum point. So you, Is it always going to be like that? The range is always going to be y and then some relationship to some number, either greater than or equal to or less than or equal to.
The vertex.
Yeah, but it just depends on which direction your parabola is facing. And then that number could change, as she said, depending on where the vertex is. Feeling pretty easy and pretty comfortable?
Yeah.
Yes? All right. I want to poke at either the top one or the bottom one, whichever one looks the most confusing to you. Unless you feel the middle one is horrible, in which case we can do that one.
Now you're gonna do is just multiply that.
The top one, because
what's
that's
in the
fraction.
parentheses.
Top one because fractions and oh my god, and then maybe do a little bit of the middle one because there's double parentheses and what the...
Yes.
Yeah, I thought it, I didn't say it. All right, first thing I need to do in my table is fill this thing out and get this thing to make some sense. So this box is what goes in, is that. So I'm just gonna, I write bigger than the box. So. Sorry, that box is too small. All right, and so what this says is everywhere I saw an X, I've put now parentheses because I'm going to stick my X values. I'm going to do that all the way down. And right now I'm not going to think really hard about what I'm writing. I'm just going to put it in there. All right. Now, fraction, okay? When I'm multiplying by a fraction, if the numerator, if the top part is a 1, then I can think of it not as multiplication of a fraction, which could be challenging, but as division by the denominator.
So negative 2 divided by 2.
So divided by 2. Okay, so I have negative 4
-4.
squared.
So negative 4 times negative 4 divided by 2.
Yes. Negative 4 times negative 4 is 16. 16 divided by 2 is 8. 8 minus 2 is? Negative 2 squared is? 4. 4 divided by 2 is? 2 minus 2 is? Okay, one more time. 0 squared is? Divided by 2? 0. Minus 2 is? 2 squared is? 4 divided by 2 is? 2 minus 2 is? See it? All right.
6. Oh yeah, I was about to say 6.
You were about to say 6. Yeah, okay, I just grabbed it from the top one. I copied. What? Something in my throat. Okay, this one's creeping me out. 5 times 5 is 25 divided by 2 is, oh my god, there's a fraction and decimal, and I don't want to deal with it. So you know what, I'm going to skip that one for now. If I don't need that point to see what the parabola looks like, I'm not going to grab it. But if I do need the point to see what the parabola looks like, then I'm going to deal with the fraction.
Can we do that?
Yes.
Oh.
Yes, your assignment, there's no X values listed for you. You get to make up any X values you want. If you realize that X value is going to do this, and you don't want to deal with that, pick another X value, or just pick the ones that give you the best look. Try to find the vertex maybe, the turnaround point, and then a couple points on either side, and you're good. Okay? All right, let's graph the thing. Negative 2, 0. 0, negative 2. Okay, I have my points, and now I'm gonna, let's see if I can do this better than the first time. I'm all nervous now. I was holding my breath. Ah, I missed that one a little bit. There it is. Yeah, but mine is bobbled a little bit. Yeah, mine too. Feeling pretty good on this one? And you could see the different characteristics, right? Like the X-Intercepts. How many does it have? Wait a minute, the first one that we did only had one. Or excuse me, had none. And now we have one with two. And then if I look at this one, parabolas are cool. Just like with our absolute values, we've got look, I remembered all on my arm. Aren't you proud of me? I've got a couple different x-intercepts that could happen.
Oh yeah, the plus signs.
The plus signs.
This, you told us to remind you though.
I know, and I remembered on my own. So proud of myself. All right, so you got three different cases that could happen. You could have a case with no x-intercepts, with one x-intercept, and with two x-intercepts. What does the graph have to look like for there to be no x-intercepts?
It's gonna be like on the
It
bottom.
has to be floating.
It's going to be floating on the bottom, or it's going to be floating on the top. Okay, so draw your favorite one of those. I like that one because it looks like he's smiling really big. Like, if there's one x-intercept, what should this thing look like? Like the one on top. Okay, so I'm just, yeah, it lands on a zero somewhere. So I'm just going to draw the one on top. Hey, look, an even bigger smile. And with two x-intercepts,
It's gonna go
They blow
through like.
it's like the one in the back.
it's like the one on the back, the one that we just did. Ta-da! That's all there is to say about these today. Thank you very much.
Thank you.
Yay!